Let's go to Liquid 2141. Maximal running time of n computers. It gives us an integer n and also an integer array batteries. It says that we are looking for the maximal concurrent for times that n computer can run. So the condition is that it's a battery. We can use the battery for when to for example use part of the battery value and use it to another computer. Um, so we need the maximal. So for the maximal value, right? We can thinking about whether it is the binary search or sometimes the DP or those kind of directions. But for this one, we can actually think easily to consider that is binary search on the target value. The reason um, here is that this is pretty much like a lot of similar questions like Coco eat a banana or those kind of questions, right? So, but the battery is that for those kind of batteries, we trying to see if, for example, if we have this kind of T, right, we can use um, for the concurrent n computers to use, right? So that is for every battery, we can if it is more than this T, right? We can just use this the sum to T, right? And also if there is we can use this battery to this time t. And if there is a computer, for example, this battery is not more than t, right? So what we want to see is that for other one, right? For example, this one we can use a T batteries, and this there is n m n computer, right? And also there are m batteries. So what we want is that we want to see if this M batteries, this sum, right, should be greater or equal to this N battery multiplied by T, this part, right? If it is greater or equal to, then we can let this N computer to run simultaneously. So that is a valid condition. So if we know this valid condition, to write a binary search, it is very simple. Let's write the binary search for this. Um, we're going to have a long start equals 0, right? And we can actually sum all of the batteries as end. So what we do is for each B in batteries, just have end plus equal to B, right? And then we'll write y start plus one smaller than n long made equals start plus n minus start divided by 2, right? So let's say if we can run simultaneously, right? Simultaneously with these batteries and n computers and this mid, right? So that means we can try to search larger, right? So we'll have start equals mid. If we cannot run, that means we should find a smaller value. So we'll have n equals mid, right? And in the end, what we do is that if we can run simultaneously batteries and n, right? Then just return n. And otherwise just return start, right? Um, the worst case is start is 0, so it will always have value. So we don't need to check can run start again, right? Then what we do is that we need the value function Boolean um, and run simultaneously. So we're going to have these batteries int n and int target. So what we do is that we're going to have a long sum because so what to do is for every battery in batteries. So we're going to have sum to the plus equal to mass dot min uh, target and the battery, right? So we'll say if this sum is greater equal to n multiplied by target, then return true. Otherwise, just return false, right? So doing like this, we are boundary search for the end, right? So this is log n. So this is say the end is maximal is the sum is d. Let's say so this is log d and can run simultaneously. That is we have an linear with battery array, right? So this is OM. So that is M log D time complexity with constant space complexity. And we can also write a Python code for this. So we're going to have start and equals 0 and the sum of batteries. Then what we do is to while 这个 let's write have function that can run simultaneously. Um, we have some kind of target, right? This is the return Boolean. And so we are going to have total equals 0 for B in batteries. So we are going to have total should plus equal to min B and the target, right? So we'll say if the total is greater or equal to n multiplied by target, then we return true, right? And otherwise return false. So for our main function, what we do is that while this start plus one is smaller than end, we're going to have mid equals start plus and minus start divided by two, right? So we'll say if we can run simultaneously mid, that means we are going to search to larger values. So we're going to have start equals mid, else we're going to have end equals mid, right? So when we jumping out of the while loop, we'll say if we can run simultaneously and just return and otherwise just return start.